The Alcubierre metric proved that faster-than-light travel is mathematically possible, but as an engineering reality, the model is broken. This matrix compares the traditional Alcubierre drive against a coherence-driven system. The classical model has two theoretical roadblocks: exotic negative mass and energy equivalent to Jupiter. The Coherent Warp Architecture provides an alternative, replacing impossible requirements with an engineering-feasible approach: hypergravitational coupling. This framework treats relativistic limits and quantum indeterminacy as artifacts of a lower-dimensional perspective. By modulating a hypergravitational field, a craft can interact with the higher-dimensional frame that anchors these systems, bypassing the constraints observed in three-dimensional space. Realizing faster-than-light travel depends on solving the mathematical challenge of higher-dimensional field geometries. This integrated spacecraft architecture serves as the physical map for that theory. The schematic is built around four primary subsystems: the hypergravitational field generator, the coherence engine, the quantum coherence sensors, and the coherenopter. Analyzing this blueprint as a functional engineering document allows us to reverse engineer the unified theory of quantum gravity required to make it fly. We will deconstruct the anatomy of this craft, system by system, to track how it bridges the gap between quantum mechanics and general relativity. The process begins with the hypergravitational field generator, or HFG, which handles localized spacetime manipulation. To function, the HFG requires a shift in how we interpret quantum mechanics. Wave function collapse is not probabilistic, but a lower-dimensional shadow of a deterministic higher-dimensional system. The HFG couples higher-dimensional fields to four-dimensional spacetime, generating curvature without exotic mass. This is governed by the hypergravitational potential equation. The critical variable, lambda c, modulates the interaction between the ship's quantum fields and the hyperdimensional frame. Modulating that constant produces a topographical shift. Spacetime contracts ahead of the craft and expands behind it. The generalized shape function shows the lambda c factor provides mathematical stability for the bubble, replacing the need for negative matter. By tuning the resonance between hypergravity and the spacecraft's quantum fields, spacetime curvature is achieved naturally, making exotic negative matter obsolete. Navigating that bubble requires the control subsystems located in the forward section of the craft. Beyond the energy requirements, faster-than-light travel faces the bottleneck of relativistic mass increase. As a craft approaches light speed, frame dragging forces and inertia typically reach lethal levels. The architecture addresses through the inertial mass elimination equation. By driving the coherence factor toward zero, effective inertial mass is neutralized. While a standard ship experiences gravitational drag, a coherent ship moves through a protected bubble. Maintaining this state requires the quantum coherence sensors, or QCS. They monitor micro-fluctuations and phase shifts via entanglement, providing diagnostic data with zero signal lag. This lag-free data allows the coheroputer to execute predictive algorithms. It adjusts the warp field in microseconds, neutralizing space-time fluctuations before they can breach the hull. Successfully bypassing the speed of light depends on this deterministic, lag-free feedback loop to manage the extreme data processing of the warp field. To address the final limitation, the immense energy density required to bend space, we look to the rear of the blueprint. The coherence engine is a self-sustaining power plant, converting hypergravitational coherence into zero-point energy. The offset equation shows how E-co, the energy generated by the engine, is subtracted directly from the massive energy required to warp spacetime. This creates an inverse relationship. As the ship's quantum coherence increases, the system automatically generates a higher energy offset. The vehicle effectively becomes a coherence-to-energy converter, leveraging the local quantum vacuum to sustain its own transit without massive external fuel loads. Viewed as a whole, the spacecraft operates as a closed-loop ecosystem. Each system supports the next. Coherence generates power, power bends the warp bubble, sensors gather phase data, and the quantum core executes the feedback to restore coherence. This mathematical model proposes a functional bridge between quantum mechanics and general relativity by treating both as specific outcomes of an invariant hypergravity field. The modular architecture allows these field reconfiguration nodes to scale predictably from drone prototypes to interstellar vessels. Physical trials validate this by mapping spacetime curvature, ensuring coherent stability, and measuring energy efficiency against Alcubierre benchmarks. By utilizing the physics of higher dimensions, faster-than-light transit becomes a process of engineering the hyperverse geometry itself.